Many chemical reactions can be accelerated by the addition of certain substances. In 1836, J. Berzelius named such substances catalysts. Catalysts are substances which change the rate of chemical reactions without themselves undergoing permanent change. There are also catalysts referred to as negative catalysts, inhibitors, which reduce the rate of reactions.
Effect of catalysts. As we know, catalyst, the function is speed up a chemical reaction by providing alternative mechanism with lower the activation energy, EA, increasing forward and reverse reaction rate to the same extent, shorten the time taken to reach equilibrium. But catalyst has no effect on the equilibrium position, means the shifting to the left or to the right, and no effect on value of Kc and Kp. At the same time, catalyst is not consumed in chemical reaction. Okay, by referring this graph, you know that initially the reaction from reactant change to product, it needs to overcome the activation energy with the red color. But when catalyst is added, it lowers the activation energy. So now the reactant easier to become the product. That's why based on just now, right, the function of catalyst is speed up the chemical reaction by lower the activation energy for both forward means like this, from reactant become product, or reverse from here become from the initially is product, now become reactant become product. Okay, reverse it. Okay, always remember EA is the symbol for activation energy. Exercise. In the uncatalyzed reaction, based on this equation given, the pressure of the gases at equilibrium, okay, so the pressure of the dinitro tetraoxide is 0.377, then the pressure of nitrogen dioxide is 1.5 atm at 100 degrees Celsius. What would happen to the pressure if a catalyst is added to the mixture? As we know, pressure won't affect the Kc or Kp value, won't affect the shifting of the equilibrium position. The answer is there will be no change in the pressure and catalyst has no effect to the equilibrium position. This is the overview for the change of concentration, pressure and volume, temperature, catalyst towards the shift equilibrium. All will affect the shift of equilibrium except catalyst. And for the change equilibrium constant means the value of Kc or Kp, no effect towards the factors or the disturbance. Only temperature will affect the Kc and Kp value. Always remember, only temperature will affect the Kc and Kp value. And then for catalyst, no effect towards shift of equilibrium, no effect towards Kc or Kp value. Exercise. Consider the following equilibrium process between dinitrogen tetrafluoride, this one, and nitrogen difluoride, this one. Okay. Predict the change in equilibrium. The change in equilibrium included the shift and the Kc value. So before, first of all, right, we need to check the phase of the equation. Yes, gas need to consider. And then this one, positive endothermic. Endothermic means absorb heat. So absorb heat over here. So heat is added to the reactant side. Okay. And then we need to check the number of mole of the reactant, 1, and then the number of mole of the product is 2. Okay, these are the few steps we need to determine or analyze first before we proceed with the question. Okay. Next, when the reaction mixture is heated, for this case, this is endothermic. So when the reaction is heated, the equilibrium will shift to the right. Why? Okay, when heat is heated or when temperature is increased, so endothermic reaction is favorable. So forward reaction is favorable. So the mixture will shift to the right. What happened to the Kc? Okay, when the system shifts to the right, in this case, the concentration of the product means nitrogen difluoride will be increased. And then the concentration of reactant will be decreased. So Kc value will be increased. Have to bear in mind that Kc value only will be affected by temperature. Okay, what happened for NF2 gas is removed? So when NF2 gas is removed, meaning that for this time, okay, I have to change it. Okay, now the concentration of NF2 is okay, this one, sorry, NF2 is removed. Now the concentration of the product is decreased. Now the system will try to increase the concentration of NF2. So the system same shifting to the right in order to increase the concentration of NF2 and decrease the concentration of N2F4. Okay, for concentration, it won't affect the Kc value. C. The pressure decrease. Based on our previous discussion, when pressure decrease, volume increase. Now you feel quiet. You want to go to somewhere that crowded, meaning that the number of mole will from fewer number of mole to greater number of mole. So in this case, okay, the system will shift. Here is 1 mole, here is 2 mole. So the system will shift to the right from 1 mole to 2 mole. And then the Kc value remain unchanged. D. Inert gas such as helium is added at constant volume. Constant volume, okay, only the P total will be changed. P total will be increased, but the partial pressure of each gases remain the same. So the equilibrium unchanged and then the Kc value unchanged as well.